Okay, so we just wanted to give you an overview of the satellite imagery available there. That was the presentation of Mark. Type of products that can be generated. There was the presentation of Inder, and the feature selection techniques that are now state of the art. And this was Guido. So now, if you don't have any written, do we have any written question? I mean, any question coming from Twitter? Not yet. So. Yes, so I will. Then I would like to propose that the panelists sit on the chair, and then we need initiate the question and answer session. Okay, first question, please.
One technique that I haven't heard mentioned is PSINSAR, which is being used mostly for detecting and tracking deformation. But the fact that permanent scatterers are generally buildings, I'm wondering if it might have an application in counting up building stock.
Is this for Guido?
The INSAR, the use of INSAR is actually quite specific to look at the change in heights in buildings. It's a bit more difficult, especially in dense urban areas. There's quite a few problems in actually deriving individual building height directly from INSAR, especially because until recent INSAR was at a coarser resolution. You have this, I mean, what we saw this morning in the Haiti presentation, where they show the displacement map after the earthquake. So you look at displacement over very large areas.
I'm not talking about conventional INSAR, specifically PSINSAR.
That's a permanent scatter, but the idea behind PS INSAR is to look at individual permanent scatterers in, for instance, city areas, but mostly to follow change in height over time. So it is not really specific to urban or at least building delineation. So it's a little bit, it has a different kind of application.
What I'm thinking is that before you can track the movement of the buildings, you've actually got to detect the buildings.
Not necessarily, no, because it's based on permanent scatters, whether these are buildings, but there's lots of artifacts that also cause permanent scattering effects. So it can be corner reflectors, it can be different, say, artificial targets. So it does not really have to be a building. But of course, knowledge of the kind of target that gives you a permanent scattering behavior is important. But you would not need to understand exactly how that is causing that formation.
Okay, thanks. Thank you. Any other question? Yes, please. Sorry.
Thank you. I'm Ole Nielsen from the Australian Government Agency for International Development, and we are really interested in this kind of work for our work in Indonesia, for example. So I've got two questions. Firstly, do you have any sense of the reliability of automatic feature extraction? Are we talking 40% or 60% for finding building footprints, for example? And secondly, are any of these tools available as open source?
Can you microphone on? Can you hear? Yeah. So reliability, maybe from the built-up areas that we showed, I showed briefly those 40 cities. The accuracy there ranges between, say, 80 and 90. So with top 95. But in that case, so you always have some cities that work less better than others. So, but that is the order of magnitude, yes. And the second question is probably soon.
True, there's a tool called OTB. It's called the Orfeo Toolbox, which is a development in open source development in remote sensing. And it has texture modules and morphology modules that you can use to derive this kind of information. Whether they are optimized to handle very large volumes is maybe an issue, but again, these are algorithms that you can, in principle, also parallelize and So if you put in some effort, that would be a possibility. Yeah, and that is.
No, I'd echo that. OTB is very good, and of course there's the GRASS software that's been around with all the traditional classification and analysis.
Okay, we have one here and one there. Then. Yes.
Hi, I'm Ed Parsons from Google. It's not a technical question, but probably a question of considerable interest. What are the issues around the licensing of data that you extract from satellite imagery? I think around Haiti, largely most of the imagery providers for that particular issue moved away from any requirement to have data licensed under normal circumstances. But obviously to do this on a more long-term process and to make this sustainable, clearly the licensing of the data that you extract from imagery will become a problem, and the cost potentially of licensing that data. Do you have any thoughts about that?
Yeah, the imagery has been acquired from the imagery providers, either on behalf of the customer or the customer has provided it to us or we have acquired it ourselves. We have processed it in-house and delivered the data in whatever format, whatever tools are available with the client. We have had cases of customers coming back and asking for updates every 6 months or every year, depending on how much urbanization, how much development is happening in those areas. And each time new imagery is acquired and new imagery is processed. So it's a one-off license for the data that's been created.
I'll just add, I think that's always been a challenge. Back in the old Landsat days, it was several $1,000s an image. Now that's freely available. I think the general trend is it's becoming more and more a commodity. Yet it's still very expensive to launch and maintain the satellites. So I think we're seeing in the U.S. where now the government's stepping in and bulk buying a lot of that sustains the business model for the commercial satellite providers, and especially in disasters, everybody releases it I think the challenges for upfront analysis and repetitive analysis. How do we get to a price point that's viable for that?
I think in general also the license allows you to, if you derive information that is not, say, reversible into the original product, including maybe downscaling of the resolution, but so processing the information in such a way that you can never get the original data out of it, that is actually allowed under the normal licensing scheme. And so derived information is usually not covered by that particular restriction.
And listening to this is kind of interesting because we were, just to put this at the highest level, we're the prime contractor to the UN for the supply of 7 sensor satellites, 5 optical, RadarSat 1 and RadarSat 2. During the Haiti crisis, Digital Globe and GeoEye both offered the data through the UN. We had a call from the UN Cartographic Service to me, I think January 13th, asking if we could request from Digital Globe and GeoEye any data that was available. So I can't remember how much GeoEye provided, but I think Digital Globe covered Port-au-Prince at least 3 times fully and virtually all of the country. I think it was about 7 terabytes of data. Getting to the licensing aspect of it, this is interesting. Derived means like an ortho product. So if you do an orthorectification of an image and the pixel values are nearly the same, or you maybe move that pixel a little bit, that's a derived product. That cannot be provided to, that would be an additional license. If you do a value added, which is extracting vectors or a bitmap or something that doesn't have the original data values, that you can give freely. And we also had done a project recently. It was funded partly through the World Bank, Government Australia. It was in the South Pacific, where the data were actually the value-added work was done elsewhere, but the licensing was such that the CDs or DVDs could be shipped to wherever the value-added work was done, with the promise that the data would be deleted. That worked out fine. So there's a big important separation here between derived and value-added. For an MDA, for a RadarSat 2, we're very, very tight about what's a derived and what's a value-added. So if you cross a line, then it's you're buying a multiple user license, which changes the price of the data. So I'm speaking also on behalf of John Roos of Digital Globe, who is here. Some of you may have seen him, and also on behalf of GOI, who I don't think there's any representation here. Thank you.
Would you consider automatic feature extraction a derived or a value-added product?
Well, that would be a bitmap, something that doesn't have the original pixel value, so it would be binary. That's fine. So if you're doing a feature extraction, extracts rasters, then you do a raster to vector, clean it up. That doesn't have the original pixel values, or again, the derived, whether you're doing an ortho, downsampling, it all falls into that derived product. So you can't just say, oh, it's half meter to start with, we're going to downsample it to 1 or 2 or whatever you want. It's still a derived product. You have to stick with the value added. So it's fairly clear in the EULAs. Digital Globe EULA, I'd say, is my personal experience is a little bit clearer than the GOI EULA, but they both follow the same course. Other vendors are a little bit different.
Okay, I think it was an important clarification. Thank you. Yes, please.
I'm Keith Porter, University of Colorado at Boulder, and my question is about the limit of difference, identifying differences before and after an earthquake. We've seen images of buildings and trying to identify which buildings have collapsed, but another important post-earthquake situation is identifying those buildings that have not collapsed but are potentially collapsed, that have a significant collapse potential. Engineers need to go out and do red tagging of buildings, and it would be really valuable to be able to know which buildings have moved so that their roof is perhaps on the order of an inch displaced relative to the ground floor, or 1% displaced relative to their height before and after the earthquake. That's the difference between a building that needs to be that probably needs to be red tagged and one that is probably safe. Is that a current capability of remote sensing to see that small difference in an automated fashion very quickly?
I haven't seen that. For example, if you take LiDAR, and if you look at LiDAR closely, it looks like the models have been stuck in an oven and sort of melted around the corners, because you don't get the clean breaks at the edges of the building. So it'd be very hard, I think, to measure that type of fidelity. And I think to get to that type of capability, it's going to take some pretty accurate before and after ground-placed sensors or at least oblique cameras to be able to detect that kind of feature.
Well, maybe in theory, a repeat pass differential interferometry would have that capability, but I wouldn't really. I mean, first of all, it would be a very expensive way to do it. But I mean, that kind of interferometry is able to measure in the order of its wavelength, which is 5 centimeters. So if you have fractional displacement of in the order of 5 centimeters, then in theory that would be possible. But this is basically the permanent scatter capability that you would. But then again, you need to have very high resolution SAR and the differential capability. So at the moment, it's not yet in space, something like that. But there's a Tandem X SAR coming up. So this is what is it? It's basically 2 SAR systems that fly in formation to allow you to do more precise INSAR. But I'm not going to bet on that it would do this kind of measurement. But
okay. The next.
So this is to follow on to the last couple of questions. I'm Katie Filbert, and I work on OpenStreetMap. And I know, like, it was, like, briefly mentioned, like up there, it's, like, first I want to correct some of, like, what was said. It is, like, on-the-ground mapping, but, like, a lot of it, like, nowadays is, like, done from, like, satellite imagery. And, like, in Haiti, that's how, like, I mean, virtually all of it was done, and then later, like, people, like, went there. But in order to make that happen, like, that was a unique situation where it made the headlines, and, like, we were able to graciously got imagery from Digital Globe and GeoEye, and then later, like, some aerial photography from, like, the World Bank and other organizations. But then, like, we had, like, the Chile earthquake, and there are other, like, disasters that happen that don't make the headlines in the same way. So we have a hard time, like getting access to that imagery, like, so, like, our users can do, like, what was done in Haiti. And then, like, the second thing is, like, we're talking about, like, preparedness. So, like, I know it was mentioned that in an earlier session about, like, say, like, a place like Panama City, which is, like, similar in many ways to Port-au-Prince, very vulnerable, and we would, like, totally love to, like, do what we did in Haiti, like, map it out, like, before, like, something happens. And I think that's kind of like what's, like, being done in Guatemala, but, like, to do that in other places. So what we really need, like your help and, like, the licensing, like, to allow, like, us to do what we do.
Thank you. I suppose it was a comment. Yes, thank you. Other questions, please? Then.
Yeah, my name is Ajit Oak from Primo Consultants, India. My question is regarding the DEM data. I would be interested to know how easily is this data available and how high is high-res that is available currently, as far as DEM is concerned.
The resolution of the DEM is actually a function of the imagery that you would use, and that then goes back to cost and time things. If you use a 1 meter resolution imagery, you would get a 2 meter DEM. If you use a 0.5 meter imagery, you would get a 1 meter DEM. Ballparkish figures like that. It's not readily available because of time and cost thing, but it can be created. I would say like a river basin area would probably take a couple months to do. That would be the time.
Sad, I'm sure you're aware there is globally available SRTM data that can be used as a base. Right.
Robin Spence, Cambridge Architectural Research. I was really impressed with the exposure data on Delhi, which our friend from RMSI showed us. But you produced at the beginning a very long list of desirable characteristics for the exposure data which you'd need in order to do risk assessment. What I'm interested to know is to what extent you get that kind of data. You mentioned that you needed to do some ground survey in order to collect that kind of data. I'd be interested to know how you go about that ground survey, what kind of input of effort it takes to produce a, let's say, level 3 assessment of a large urban area, and what kind of skills you need in that ground survey data. Is that the kind of thing that could be substituted by crowdsourcing methods, or does it need skills that the ordinary person in the street wouldn't actually have in order to help assemble that data?
The amount of secondary data actually varies by country to country where we are working in. So in India, because we are based in India and the Indian government does have a building inventory database for the country. In Romania, we could get from the National Institute of Statistics a building distribution. But in several other parts of the world, this has to be collected. It can be done through crowdsourcing because what you need is a lot of guiding on what is the kind of information we want people to provide us. It was mentioned in one of the other presentations that it's actually the engineers who could do the classification. So a photograph of the building, you don't need every building covered. If you do a sampling, that would actually help because the spectral signatures on the imagery are consistent. So we could actually pinpoint certain areas and say that, you know, these are the areas you need to go and get a sample for. Blocks of apartments in one area typically would have similar characteristics, for example. So it would need a little bit of supervision. Otherwise, it can be done generally. The luck part comes in as to how much data each of the developing countries actually already has. And as much of that as possible will improve the quality of it.
I guess I have a couple of I'll do a two-part question here. I'm Steve Arnold from Vandenberg Air Force Base. The spectral differencing aspect, I guess, given the fact that you have very little data in some regions of the world on specific building characteristics, how much utility have you gotten out of things like spectral differencing and stuff? You still need some of that additional data in order to get that to work for you. Is that true?
Yes. Do we have other questions? Maybe. Twitter, no question coming from outside now. So, yes, please go ahead.
My name's Ryan Engstrom from George Washington University. And just a quick question in terms of costs, in terms of like level 3 data, you showed India and you showed the multi-level approach. About how long in terms of man hours and person hours you're putting into something like that, and how about costs to do a whole country like India at the multiple levels, like for individual cities? And what size cities do you like focus on in terms of, do you consider large cities?
That's actually the reason that we do it at different scales, because doing level 3 for the whole country of India would take a couple of years of a lot of effort and a lot of money to do that. So the approach that we take is do level 1, overlay that with hazard maps and other maps. The areas that are at high risk or of interest, for those areas you do the level 2 and do that. In terms of costing, we normally do the pricing on a per square kilometer basis, where the imagery cost also is on per square kilometer depending on resolution of imagery and then the processing time. It's also a function of number of land use classes, number of vector classes that you want to extract out of it. I could give you some ideas on different types of it. I can share that with you. We actually have about 60 countries and about 3,000 cities at one of these resolutions that we have. So the pricing would be a function of availability of secondary data, availability of imagery, vintage of imagery, all of that. I'll give you some details offline. I would actually not know that off the top of my head, but if you were to do the level 1 for all of India, it would be, I would say, in around the $100,000 mark. Individual cities, the example of level 4 I can do is, we did all of Hong Kong and Kowloon at level 4, which was about $250,000 and took 3 months to do. Those are ballpark ranges.
Test. Lloyd Lynch, Seismic Research Center, Trinidad. To what extent is the exposure of buildings to, say, minor events, well, not very damaging events, being used to validate information that has already been calibrated And is there a strategy within the community that is used to do this?
I think this is it goes beyond me. I would not be able to answer this question.
I don't know, the question that you were asking, when we actually do the modeling, we do take the value of the buildings as an indicator of potential loss. What we also do to calibrate the model is actually go back and look at historical events and compare the losses reported versus that. That's one way of validating it. However, there are also with the actual reported data itself, is that consistent or not? But we do look at the areas of damage, the number of buildings damaged, and in historical events, so that we are sure that the models are predicting the correct things going forward. That's about all I could think of for that answer.
Just a quickie for the last speaker. What's the actual value in terms of increasing the detailed geometry of the structure in that one slide that you showed? If you go beyond a simple block shape, what does that do for you?
Well, I guess it's giving you further clues on to the value of the building itself. So the more detail you collect, the more precise you can actually estimate the say attached value to something like that. But it's, I mean, that slide was, I mean, it goes beyond just the exposure information there. I guess it just shows you that increasing the detail, increasing the effort is of course leading to higher, say the higher demands for the input data and additional manual work. So that's, I mean, in terms of cost, that was the message of that slide.
How far do you actually go then, in terms of when you're modeling?
Well, that is again our question back to the community, is that how far do you want us to go? So I mean, until now, I guess we do not go as far as suggested in that slide, but where circumstances would require this kind of information, it is technically it would be feasible. So, but that again, that is the feedback that we would expect from the risk community, is to giving these potential technologies. What would you want to have? At what detail? So same as the level 1 to 4. I mean, we can probably extrapolate that to level 6 if you want, but it has, of course, additional cost implications.
Any other question? If not, I would like to close the session. Thank you very much to everybody, especially to the speakers. Please a round of applause for the speakers. Thank you very much.